that my face is needed on this video, but whatever. This is the second period video, and we'll do 2, 5, 8, 11, ... And hopefully the hardest part is keeping up with what number we're doing rather than the actual calculus. So again, first period video is 147. Fifth period video will be 369. Number 2. Let f be a differentiable function with selected values given in the table on the right. What is the average rate of change over the interval from 2 to 8? Average rate of change, what's that mean? Slope. Algebra 1, slope. Change in y over change in x. y2 minus y1 over x2 minus x1. Rise over run. All of those words. But from 2 to 8, so let's make sure we pick off the right values here. So the change in y values would be negative 15 minus 7. And the change in x values would be 8 minus 2. So that's negative 22 over 6, which is negative 11 over 3. Answer choice A. It's an Algebra 1 computation with a calculus terminology. Number 5. Find the slope of the line tangent to the graph of this thing at the point when x equals pi over 6. Slope of the line tangent to the graph. So what's it asking for? What's slope of the tangent line asking for? The derivative. Did I show you all the Spider-Man meme yesterday?
Yes.
Okay. All those different words that just mean find the derivative. At pi over 6, so we'll have to plug in when we get done here. So derivative of tangent is secant squared. And the derivative of cotangent, well, if tangent goes to secant squared, then cotangent goes to negative cosecant squared. And I'm really not sure I would know the derivative of cotangent without looking at the derivative of tangent, because that's how I have the cos memorized. Okay, when x equals pi over 6. So secant of pi over 6 squared minus cosecant of pi over 6 squared. Pi over 6 is the shallow angle. Secant goes with cosine, root 3 over 2, but I flip it and get 2 over root 3 squared. So that would be 4 over 3. Cosecant is the flip of sine. Sine of pi over 6 is a half, so I flip that, I get 2. 2 squared is 4. So that's a safe stop answer. Actually, all the way back here was a safe stop answer. But obviously, multiple choice wants us to clean that up. 4/3 minus 4. It's definitely going to be negative. So let's see, 4/3 minus 12/3 is negative 8/3. A little bit of calculus, a little bit of trig, a little bit of fractions. By the way, there is partial credit available on multiple choice questions. Did I say that already? Then this would be a good example. If you get the wrong answer, I'm going to look over here and see if you were, sort of on the right track and you just messed up some fraction work, or if you just wildly guessed and you didn't know what was going on. That's the different level of points off. Number 8. Okay, just straightforward find G prime. Again, I guess it's just me, but the 4 there bugs me because it's it's trying to throw me off on what's the outermost function, like what's the wrapper. So if I'll rewrite it with the 4 out there, then I think it becomes clear that that power of 4 is the wrapper to the problem, the outermost thing I need to worry about. So 4 times all of that stuff cubed, right? That's the power rule. Now all the stuff stays the same because we only do one thing at a time. So sine of 5x. Working my way in, the next thing is the sine. Derivative of sine is cosine. So cosine of 5x. And then lastly, the derivative of 5x is 5. And then obviously they've cleaned things up. 3 times 4 times 5 is 12 times 5 is 60. A, there's not enough stuff on A. B has a sine cubed and a cosine, so I like B. Chain rule with 3 links in the chain there. The 5th power, or the 4th power, the sine, and the 5x. Number 11. Given b of x equals this thing, find db dx. Again, it's just another term or another way to ask for a derivative. What's the main rule that's going on for this one? Quotient rule. How'd you know to use the quotient rule? Right, there's dividing going on. So I've got a top and a bottom. Again, for quotient rule, I like to write out the stuff, the pieces. I think there's too much going on to try to do it all in your head. But if you want to try it, knock yourself out. Derivative of cosine is negative sine. Derivative of x to the 6th, 6x to the 5th. Now I've got all the pieces. I remember that I want my relationships as well as my quotient rule to work. So gf prime comes first, minus fg prime over g squared. Okay, so let's put all the pieces together. Gf prime would be x to the 6th times negative sine of x minus, so that was gf prime, minus fg prime, 6x to the 5th cosine of x, all over g squared, so that would be x to the 12th. None of my denominators have x to the 12th. What's going on here? What can I do? I don't think I did anything wrong. How do I get from this to one of these answers? Yeah, there's an x to the 5th in everybody, so I could reduce this whole thing by x to the 5th, and that would leave me with negative x sine x minus 6 cosine x all over x to the 7th. Okay, so that explains x to the 7th. Why is which one negative?
The x in the front.
This one?
Oh, okay.
Because this negative, I just moved it out front to make it look better. So I'm looking for both terms to be negative. Oh, I see what they did. In answer A, they just took that negative sign and put it out front so that it goes to everybody. So it's answer A. Because the negative goes to x sine x and to 6 cosine x. So yeah, answer A. 14. I'm glad we hit one like this. We didn't in first period, so we paused and did one like it anyway. What's going on 14? Can you tell what does that look like? What does that setup look like? So what does 14 look like? I mean, it's a limit. H goes to 0. There's some H's in there. I think that looks like the definition of a derivative. But a derivative of what, I guess, is the question. Limit H goes to 0. F of x plus H minus f of x all over H. That's our formal definition. So what am I taking the derivative of? What's in the f of x spot? So I think this is the derivative of sine of x at pi over 6. So I'm not really dealing with limits. I mean, it's a limit problem, but I'm not really going to work it like a limit problem. I'm going to work it by finding f prime, because I know the derivative of sine is cosine. And at pi over 6, cosine of pi over 6 is root 3 over 2. So like computationally, it's not a difficult problem. But conceptually, you have to recognize that this setup is asking you to find a derivative of sine at pi over 6. So forget the limit stuff, just find the derivative of sine at pi over 6, and that's your answer. So it's a really tricky way to ask a straightforward question. Uh, 12 is like it as well. 14, 17. An equation of the line tangent to the graph. So I need point and slope. What time do we get out of here? 9:10? Oh, good. Perfect. Equation of the line tangent to the graph at the point. Oops. So they give me the point. That's nice. I need the slope, which means I need a derivative at that point, and then I can put it all together to get the equation of the line. What's it going to take to get the derivative of this thing, though? Chain rule is part of the answer, but quotient rule is also, product rule is also part of the answer. I think I should probably write both of these down because this is more complicated than the super easy product rule question. So the derivative of f is 1. The derivative of g, 3 times 1 minus 2x squared times negative 2 because of the chain rule. So negative 6, 1 minus 2x squared. But that's just the pieces. Now I've got to put it together. So f, it's product rule, so it doesn't really matter which way we go. F prime g, so 1 minus 2x cubed, plus, that was this way, f g prime, x times negative 6, 1 minus 2x squared. So I kind of put that in a cleaner spot. So that problem combined product rule and chain rule. You need a chain rule to get one of the pieces, but then the product rule to put it all together. And I need to evaluate that at 1. So I could clean up first, but it's probably easier to just plug in 1 and see what happens. 1 minus 2 is negative 1, cubed is negative 1. minus 6 times 1 times 1 minus 2 is negative 1. Square that, we get positive 1. Negative 1 minus 6 is negative 7. And I look at my answer choices, and that's great news, because I don't really need to write the whole equation of the line. Only one of those has a slope of negative 7. So I didn't really need to write an equation, because I was able to find my answer before I got there. I mean, this is a good picture of what calculus looks like the rest of the year. It's not just like, here's one little problem where you practice the same thing over and over again. It's like, hey, here's a problem that uses a trig rule and a quotient rule and a chain rule. And then use all that to find an equation of a tangent line. It's like, occasionally, yes, you get some straightforward problems, but usually you're trying to put multiple things together. All right, last one. I don't know if this is easier or harder, but there's no come on in. There's no functions there. They're just names of functions. So I don't have to know any of the specific rules. All I need to do is use the product rule. What's the 2 marks mean? Second derivative. So I need to find the first derivative and then take the derivative of that. So product rule is one of them times the derivative of the other plus the other way around. So I guess v times u prime. So again, in some sense this is easier because there's no specific rules I have to know other than the product rule. I was kind of surprised that wasn't an answer choice. It's not right, because I need to find another derivative of that. So how am I going to find the derivative of u times v prime? What rule will that take? U times v prime. They're being multiplied. So that would be the product rule. So the product rule is one of them times the derivative of the other. So u times v prime plus the other way around. So I'll take v prime times the derivative of the first one, which would be u prime. It might be easier to say I did the first times the derivative of the second, and then the second times the derivative of the first. And then I need to do that again on the second term. So I'll phrase it that same way. The first times the derivative of the second plus the second times the derivative of the first. And this has 4 terms. None of my answer choices have 4 terms. What am I missing? What do I need to do? I got like terms in here. V prime, u prime, there's 2 of them. And so it's answer choice A. So sometimes we write questions that test all sorts of things. Other times we can write a question that the only thing that's tested there is the product rule. Right? There was no trig, there was no powers, there was no quotient, there was no chain. It was all just product rule. All right. So that's a third of the review worksheet. I'll post the other 2/3. Well, one of the thirds is already posted. I'll post the other